with our top priority, and we're going to cover the skill weekly aerial device visual inspection and operational tests. The reason we're going over this one is because maybe it was our fault as instructors, but we hadn't devoted enough time to it in the hot sessions in previous classes, and we noticed that we were lacking as a group when it came down to skill testing as far as the knowledge base. The other skill that we're going to put on the back burner right now was going to be the preventive maintenance skill. And the reason we'll put that on the back burner is because everybody here should have already been through the engine relief driver program, right? And so in that program, you've already done preventive maintenance on an engine. We kind of tried to pinpoint any major differences between a preventive maintenance process for an engine and preventive maintenance for an aerial, and it's pretty much the same thing. So we're going to put that responsibility back on you guys to follow the skill sheets, go through it step by step, make sure you got everything covered on that preventive maintenance, and you guys will be able to take care of that with your drivers, with your owner's manuals, with us at another time. So for right now, we're going to be dealing with the preventive maintenance. The weekly aerial device visual inspection and operational test. The way we think about this is the preventive maintenance is to make sure that all the operating systems of this truck for driving is going to work. This is a check to make sure that all the operational systems for the aerial function is going to work. It's somewhat analogous to doing a floor test on an engine. You do the preventive maintenance to make sure our tires are good, our steering is good, our frame is good, our brakes are good, all the stuff that has to do with driving is good. And then you do the floor test to make sure that all our plumbing is good, all our pumps are good, all that stuff is good, all our gauges. The weekly aerial device visual inspection operational test is the floor test of an aerial device. Does that kind of put things in perspective? All right. The reason I'm trying to paint that picture for you guys is we've had people confusing preventive maintenance and the operational check. Like when I ask them to do operational check, they start trying to tilt the cab, and that's a different skill altogether. So you'll notice just in the title itself, weekly aerial device visual inspection and operational test. So you look at the skill sheet, it's the same way. It's a two-part thing. First, we're kind of going to just leave it as it lays, put eyes on it just the way it is right now, kind of do a hot lap, top to bottom, make sure everything looks good, stowed and not operating, and then once we make sure that looks good, we'll start operating it and making sure it functions properly, and then we'll also do an additional visual inspection after we have the aerial apparatus in a different configuration so that we can see things at that point that we can't see now. Does that make sense? So if you guys want to follow along with me, I'm pretty much going to be going step by step on this skill sheet. So let's start with the first step, which we're going to have to bypass actually, because we would be wanting to check the hydraulic fluid level in the reservoir, which is typically going to be on the top of the truck, but in this case we don't have any clearance with that access under the aerial, so we can't check the hydraulic reservoir without moving the aerial, which to me seems kind of counterproductive because you will not be able to make sure that we have the right amount of hydraulic fluid, because if the aerial is moved to the side, we're going to have hydraulic fluid in the system and not in the reservoir. That makes sense, but we'll move on from there. Stowed stabilizers. We're checking for, this is going to be a common theme, and you're going to get sick of me saying it, but I'm going to keep harping on it. Common themes we're going to be looking for are checking for damage, wear, things of that nature, and leaking hydraulic fluids also going to be a big one. This entire system, both the stabilization and the aerial function of that ladder on top, is all based on a hydraulic system. We got a power takeoff coming out of the motor that's powering a hydraulic pump that's going to be pressurizing hydraulic fluid throughout the entire system, both in the stabilizers and in the ladder. So we're going to be looking for wear, damage, and leaking hydraulic fluid throughout this entire deal. Stowed stabilizer, like I said, damage or leaking hydraulic fluid, etc. Ensure the warning lights are clean and undamaged. We don't have one. This truck is almost 20 years old by now, so it doesn't have a lot of the safety features that we've grown accustomed to. So all of our newer trucks are going to have a light on the outside of the stabilizer. So that's the one they're referring to here. Making sure the warning lights are clean or undamaged. Checking stabilizer pads and stowing slots for damage and serviceability. Nothing rocket science here. We got a stabilizer pad here, stabilizer pad here. We just want to make sure that the pads are there, that the brackets are good, and that we can take them out when we need to take them out. We'll go slightly out of turn here, so we're going to skip down to part D so that we're not constantly going up and down. Inspecting the stabilizer control station. This is our stabilizer control station. These are our stabilizer controls. This is what's going to allow us to bring the stabilizer out and bring the jack down. So again, we're looking for signs of wear and damage. Nothing new here. Ensure controls move freely and return to neutral position, when released. So we want to make sure they move freely in every direction and that they go back to neutral when they're released. That's very important, not only with the stabilizers, but especially with the aerial. We don't want a runaway aerial that's continuing to move after we've stopped activating the controls. All right, so we can head up top and we'll take a look at what's going on up here. As we're heading up here, I'd like you guys to take a glance in here and kind of just look at the mechanism that is underneath this turntable right here. All right, if we don't have a very good visual on it on this truck, on other trucks, on the newer trucks, we can see it a lot better. In fact, from a lot of trucks, you can even see it from the ground. What I was hoping you guys could get a look at is that big gear under this turntable, and that's going to be the mechanism that allows this thing to rotate left to right, counterclockwise and clockwise. And basically the way that this works is we have that very large gear which is connected to the frame of the truck, connected to the ground and stabilized. Then we have a hydraulically powered drive pinion right here, if you guys want to take a look at it. Basically what that's going to be is a smaller gear that's hydraulically powered that's going to mesh into that large gear. As we activate the controls, that drive pinion is going to spin one way or the other, and that's the mechanism that causes this aerial to rotate left to right. So we want to put eyes on that to make sure that everything looks good with that. Again, we're looking for visible damage, gear meshing, alignment, evidence of wear, adequate lubrication. Grease should be caked onto this thing real nice to make sure that gear those gears can mesh up properly. Checking turntable bolts for presence and tightness. That's just going to be something that we're doing at all times, always with our trucks. Both preventive maintenance, floor test, this skill, just making sure everything is where it needs to be. Check equipment storage areas adjacent to turntable for potential turntable and/or gear teeth obstructions. Not really a problem with this one, but as we continually load down more and more stuff, especially on the quints where we have bundles strapped to the back and cribbing and push brooms and all types of things under the aerial, you want to make sure that it's out of the path of travel of this thing, because if we get things caught up in there and wedged in there, that's going to be problematic. So make sure everything is free and clear. All right. Pedestal control station. Same type of thing that we looked at the stabilizer control station. We'll flip this guy up and we'll activate these things, make sure everything moves the way it's supposed to be, make sure nothing's damaged in here, make sure it travels back to neutral when we're done activating it. We'd be doing the same thing that we'd be doing here. Anywhere else, there's controls for this aerial device. We're gonna have controls here at the pedestal. For the quints, there's gonna be tip controls. For the buckets, there's gonna be bucket controls. Somewhere down the line, and I'm not sure how the years match up, but when we first ordered quints, they didn't have them, and now they don't have them, but somewhere in the middle, there's a few quints out there that have tip controls, aerial controls at the pump panel. So if you have those on your pump panel, you're gonna wanna do the same thing. Make sure clean, undamaged, not any wear, and they're operating the way they're supposed to be. They are operating the way they are supposed to be. Excuse me. Pump panel control station. Inspected, tested breathing air supply system. Is anybody here on a bucket? You are. All right. Are you down? Is it 36s or centrals? All right. From what I understand, you guys don't have your bucket right now, but it should be coming back soon. All right. So you're going to be teaching me about your breathing air system. You're gonna be an expert on that thing, and you're gonna come down and I'm gonna sit here and stoke it all in. All right. And some of the things we're gonna be looking for is just there's gonna be some differences, but we can think about this as just a oversized SCBA. So the same things we're gonna be looking for on an SCBA, we're gonna be looking for making sure we got the good pressure, making sure our cylinders aren't damaged, making sure the hoses are good. Hoses, tubing, air connections, all that type of stuff. Sounds good? All right. We can have some people walk on the side, maybe some people walk on the ladder itself, and we will inspect the aerial device extension and retraction system. We just took a look at the gear and pinion on the turntable that makes this thing rotate left to right. And so now we're going to take a look at what makes this thing extend or retract. So you can see a hydraulic cylinder right here, and then you see another hydraulic cylinder right here. And then you see a system of cables that are connecting the base section, the lower mid, the upper mid, and fly section. 4 sections on this aerial. All the quints have 4 sections typically, I believe, and the buckets are going to have 3 sections. So the way this works is we have a long, relatively speaking, hydraulic cylinder that is fully extended when the aerial is retracted. All right? So this piston is extended right now. As we activate the control to extend this aerial, that piston is going to shorten up and pull. The end of this piston is a pulley. So it's pulling down on that pulley, and all this cable systems are connected together, and they cause the ladder to extend. Very similar, or not similar, in the exact same way that a halyard of an extension ladder would extend it. We pull down on the halyard, which causes the extension ladder to lengthen. This is a 4-section extension ladder, except it's powered by a hydraulic 600 horsepower motor and not you. But it's in the same manner. So, and again, this stuff is important that you understand how this thing works, because you'll be able to identify when it's failing. And we've had problems with that up until now. So we know how it rotates. We know how it extends and retracts. Let's stick with the extension and retraction for a second. Visible damage and wear. We're checking the hydraulic cylinders like we always are for damage, fluid leaks, and insecurity. So making sure they're connected where they're supposed to be. We're going to check the cables, corrosion, broken strands, excessive wear, proper tension, stretching, and damaged end connections. So This is what's going to house all of our electricity. That's going to be able so that we can light those halogens up there. We can power those halogens. We got these are our steel cables here for the upper sections. You can see our cables on the down there are thicker in diameter. You can see these aren't load bearing right now, so they're going to have a little play in them. But if there's any vertical element to this aerial and it's extended anyway, if this thing is really loose, that's going to be a serious cause for concern, because that means that this thing is not holding the weight it's supposed to be holding. If that makes sense. Let's take a look at an end connection. See them right here. Want to make sure that these are good, because this is what's holding. These are what's holding these cables to these sections. So if something's wrong here, this thing is going to fail eventually. Sheaves, guards, guides, and all other surfaces in contact with the cables. A sheave is another word for these pulleys. All right, guards and guides. Anything else that's going to make this, that's going to direct this cable in the manner that it's meant to be moving. All right, so we know how it extends and retracts, and we know how it rotates. Let's head back to the turntable and we'll see how we lower and raise it. Yeah, the rust is all right. It's just make sure the integrity of the steel itself is okay. All right. Hoist cylinders. You can see here we got some heavy duty hydraulic cylinders connected to the turntable itself and one end, and then connected, and then connected to the base of the base section on the other end. As we activate our controls, we send hydraulic pressure into this cylinder right here. It begins to extend and thereby causes the ladder to elevate. Inspected bedded aerial device sections. So, like I already touched on, we got a 4-section here: fly section, upper mid, lower mid, and base section. What are we looking for with this? Like always, visible damage, wear, cracks and welds, loose or missing parts, and improper alignment. We'll be checking the beams, rails, alignment system, and again, some of these things that we put a visual on them now, but we'll be able to see them in more detail and have a little better vantage point. After we operate this thing, we'll put it over to the side and extend it a little bit, and we'll be able to see this stuff have a better angle on it. But alignment systems we'll be able to see that better. But this is a series of guides and rails, just like we have on an extension ladder, that's making sure that this thing goes straight every time. Truss work. What's a truss? Triangles. It gives us strength, but it doesn't work if we're dependent on the geometry. So if the geometry is not connected, we're in bad shape. So make sure all the welds are good on that truss work. Elevating platform assembly for you, Kessler. You have the benefit of that bucket, but you got to make sure everything is good in there. Railings and hatches, kick plates, deck, heat shields, all that stuff. Make sure it looks good. Platform leveling system. That's an important thing. We always kind of take it for granted that somehow that bucket magically knows to stay parallel with the earth, regardless of what angle we have that aerial at. But the fact of the matter is, there's hydraulic cylinders here. There's some more hydraulic cylinders where that platform connects with that aerial, that maintains that angle and makes sure that you have a nice flat place to stand. I don't know if anybody saw it recently in Firehouse. I'm not sure where it was, but a crew inside a platform had to get rescued by another crew from another platform because their leveling system went haywire on them, and there was like almost, and they're almost inverted. So make sure that leveling system and those hydraulic cylinders look good. Inspecting the rungs, obviously it goes without saying, this is what you're going to be stepping on, so we want to make sure they're good. Visible damage, looseness, loose rung tread covers, welds, cracks, evidence of cable abrasion, all that stuff. Retracted aerial waterway and monitor system. It's another example of, we can kind of see it now, but when we move this thing over to the side, we'll be able to get a better look at it from down below. It's our aerial waterway. It's coming up out from the bottom here. It's a 4-inch Amityville telescoping waterway, capable of somewhere in the area of 1,250 GPMs. Max operating pressure is 250 PSI. On the buckets, they're going to throw a 5-inch plumbing on that so that you guys can get your 2,000 GPMs. You want to make sure, just like we're looking at all this stuff, we could be flowing upwards of 1,000 GPMs through this thing. We want to make sure the structural integrity is there. We're going to be checking for visible damage to the piping, connections, and seals. And again, once we swing this thing out to the side, we'll have a better look at it. So let's move to the front, to the end of the waterway, and take a look at the monitor. So we use the word or the term pinnable waterway for our ability to move this monitor in two configurations. One in firefighting mode, so we attach the nozzle to the end of the fly section so that we can have the best reach on that stream. And our other configuration is in rescue mode, so we're attaching it to the tip of our upper midsection or further on down that fly section so that the nozzle doesn't get in the way of us placing this in the window. We use the term pinnable waterway because we used to have to remove a pin and place it in each different configuration. Now we have that double action cam, which allows us to move it from one configuration to another. But here we have this nice vintage truck where we can actually see that there is a pin that we actually have to remove and to place it from rescue mode right now into firefighting mode up here. You guys on your trucks, you definitely want to exercise that lever shift to make sure that everything works properly, because if you need this thing in firefighting mode, you need to be able to get it in firefighting mode. If you need it in rescue mode, you need to be able to get it in rescue mode. And by all means, make sure that it's definitely in one or the other, because if it's not connected to one or the other and this thing for some reason gets charged, now we can have serious problems. All right. Check all monitor, nozzles, and appliances. So you can see our monitor up here we have our 3.5-inch threaded outlet. We do not actually have any type of nozzle on there right now. It's a constant debate in AFD, and I think it's a good one. Some people like the fog, some people like the smooth bore, some people want a stack tip for options, some people want just a 2.5-inch smooth bore on there. Whatever you and your crew decide, whatever your captain decides, that's what you go with. But you want to make sure that you come up here and put eyes on it and make sure that it looks and functions the way that it's supposed to. All this stuff, check electrical connections of monitor remote for tightness, evidence, and wear. The way this thing moves left to right, up and down, and when you have a fog nozzle on it, goes from a fog stream to a straight stream, is all through electrical motors. So we got to make sure that the motors look good, that all our connections are good. You can see on this wiring right here that we got some serious dry rot. If this thing weren't a 20-year-old reserve, that would be a definite cause for concern. But if you guys want to get a look, these are our motors here. It's our connections. This would be our connection for a fog nozzle. We thread the fog on here and make sure we connect that. That way we'd be able to operate this toggle here and go from a straight stream to a fog. All right, any questions on that? All right, we'll skip ahead real quick to O. Inspect equipment attached to aerial device. That's when I first came into the department and I went to a multi-company station. We had roof ladders, we had pike poles, we had pickhead axes, Stokes baskets, all kinds of stuff attached to the aerial. It seems like we might be going away from that a little bit, and I'm not really sure why. That stuff is good to have when you're 60, 70 feet in the air close to a roof. You don't have to go all the way down. But anyways, long story short, whatever we do have attached, let's make sure it's attached. We don't want this stuff falling off. If an axe or a pike pole falls off this aerial from, you know, any type of elevation, that's going to be very problematic, needless to say. Also, with that being said, we don't just want to make sure it doesn't fall, we also just want to make sure that it doesn't get caught up in an extending section. I can speak of a personal lesson learned at Ladder 8 when we had a Stokes basket on the outside of the aerial, and then we had a backboard on the inside of that Stokes with the straps. One of the straps got caught up in the extending section, pulled the backboard, and then we bent the Stokes and the aluminum hangers. So that could have been avoided, or maybe not, but do everything you can to make sure stuff like that doesn't happen. All right, let's head on back down and we'll take a look at the waterway intake. This is it. Nothing too crazy about it. With all the quints that we're ordering these days, this is not going to be as significant as it used to be. In fact, I believe that with all the quints nowadays, they're Loctiting this shut, because if you're bringing in a 5-inch supply to a quint, you want to bring it into a side intake so that you have the ability to pressurize that through your pump, instead of, if it comes in back here, you're at the mercy of whoever's sending you the water. But back in the day, with the dry ladders, this was where we were getting our water. So you want to check, make sure everything was in good condition here. One interesting thing of note: all the ladders that I worked on didn't have any valve here. So when water came up here, it was going out the top, which could be problematic if there was any type of miscommunication and that nozzle wasn't pointed where it needed to be. Here we have a valve, an electrically activated valve. I'm not sure why we went away from that, but just thought that was kind of interesting. Last thing, I guess, for the visual check is our aerial drain. I'll give my 2 cents on it. I'm not really going to say it's right or wrong one way or the other, but I would like you to put some thought into it so that if you get asked about it, you can say why you have it one way or the other and know why you do it that way. Throughout the last couple of classes, I always ask people if this is open or closed, and it seems like they're always saying it's closed, and they're saying in such a way that, like, of course it's closed because it's a drain valve, like similar to what we would expect on an engine with our drain valves. We always want those closed, right? Because when they're open, they can cause problems. So of course we'd want this one closed. And I think it's a little bit of a different ball game, because if this stays closed and we don't really have a good understanding of our system here, it can cause some problems. And the problems that it can cause is if this is relatively airtight and we got this drain closed and our discharge up top is airtight as well, and we try to extend this thing, you can see we're kind of creating a vacuum inside of that telescoping waterway. And I've heard urban legends of that waterway collapsing or definitely causing damage to the seals, or even without causing the damage, we're just making that aerial work that much harder to extend that ladder, all right? Vice versa, if we have it closed and we have everything closed off and that waterway is charged full of water, and now we try to retract it, we definitely know that water is not compressible. So again, at best case scenario, we're making that aerial work harder than it should. Worst case scenario, we might be causing damage to the seals or causing that waterway to bust. So what I tell people is I always drove around with this thing left it cracked, because when we're flowing thousands of GPMs worth of water, if a little stream of water shooting out of this drain, in the whole scheme of things, it's not that big a deal. But keeping this thing open will allow for water to drain out as we're retracting that waterway, or air to go in as we're extending that waterway. So take that for what it's worth. Talk to your drivers, talk to your captains, and see what their thoughts on it are. All right, that will conclude the visual inspection.